Welcome to Mathematics Lecture Series, lecture number 20 in Laplace transform. Application of Laplace transform. We discuss now solution of initial value problem. Before the start of lecture, I request you kindly subscribe the channel to click the bell icon and like the video. Solve the initial value problem y double prime of t minus 3 capital Y prime of t plus 2y of t is equal to 4 e power 2t. Y, there are two initial conditions are given. Y at 0 is equal to minus 3, y prime 0 at is equal to 5. This equation is given. Now taking first step is always constant, that you have to take in the Laplace transform of both sides. Laplace of y double prime of t 3, Laplace of y prime each term, take the Laplace of each term. So Laplace of y of t and Laplace of 4 e power 2t. Laplace of y double prime of t s square Laplace of y of t, which is equal to y of s minus s y capital Y at 0 minus y prime at 0. So double Laplace or double derivative of t is this equation. If you haven't remember or haven't idea, then you can watch my series, the Laplace of derivative lecture. Minus 3, here Laplace of y prime of t is Laplace of y of t capital Y, so this is denoted by y of s minus y at 0. So this is Laplace of y prime of first derivative of t plus 2, here Laplace of y of t, which is denoted by y of s. Here 4 Laplace of e power 2t is equal to 1 over s minus 2. By the formula, Laplace of e power at is equal to 1 over s minus a. So using the given conditions here, these conditions used in that, y at 0 is equal to minus. So we have replaced y at 0 is minus 3 and y prime at 0 is equal to 5. Y prime of 0 we replace with 5. Minus 3 as here y at 0 again use minus 3. So 2 of y of s 4 is minus 2. Here taking the common y of s, so s square is erased here. Another term of y here, this is a y of s term minus 3s is there, and here plus 2. Other term take to another side, or we can say add and subtract both sides. So we will have 4s minus 2, here minus into minus plus 5, so subtract both sides 5, we will have here a plus 5. Here minus into minus plus, plus into minus 3, so 3 into 3 9, so add both sides plus 9, so 5 plus 9 is equal to 14, and here we have this minus 3 plus 3, we subtract both sides plus, so here we have plus 3s. Now divide both sides, s square minus 3s plus 2, you will have here y of s 4 s minus 2 s square minus plus 2, here minus 3s plus 14 divided by s square minus 3s plus 2. So y of s, taking the LCM, you will have the LCM s minus 2 s square minus 3s plus 2. So here is a 4 is raised here, s minus 2 must be multiplied 14 minus 3s. So we will have 4 plus 14s minus 20s, 28 minus 3s square plus 6s. Now we have s square minus 3s plus 2 is equal to s minus 2 s minus 1, you can check it. So s square minus 3 we replace by these two factors s minus 2 s minus 1. So it becomes s minus 2 square s minus 1 in a denominator. Of course, in that situation, here is the degree is a greater than of the denominator from the numerator, so we can use the partial fraction. So we will solve this by partial fraction. So now partial fraction, Here a over s minus 1 first partial, second partial b s minus 2 square plus c s minus 2. Multiplying both sides s minus 1 s minus 2 whole square, so we will have minus 3s square by 12 plus 24. Here a multiply with this s minus 1 s minus 2 whole square, so one factor will be cancelled, s minus 1 with s1, then you will have s minus 2. B multiply s minus 1 s minus 2 square, so this s minus 2 will be cancelled, you will have s minus c. Here s minus 2 is and s minus 1. So this is the equation stored. Now apply the fractions, s minus 1 is equal to 0. So from which we have s is equal to 1. So put both sides of this equation 1. S is equal to 3. S1 is equal to 20. S replace with 1 minus 24. A s is equal to 1 minus 2 square, b s minus 1, so it becomes 0, and c s minus 1 is 0, so c is also 0, so we will have just a1 minus, here from by simplify we will have the value of a is equal to minus 7. Similarly, if you apply s is equal to 2, put in both sides of equation 1, and after simplification, simple simplification, you have the value of b is equal to 4. Now how can we find the value of c? For this we adopt another way. For find c, we rewrite the equation, we write this equation, so we just write an s square as, rewrite the equation, or we can say you don't rewrite, you just comparing the coefficient of s square on both sides. So from right hand side the coefficient of s square minus 3, from here you can see the coefficient of s square, so a, here is no s square, so from here you can see s multiply s, so another coefficient c, so c a is equal to minus 7, apply in this equation, so minus 7 plus c is minus 3, c is equal to 4. So we will have a, b, c values, apply this equation, put in this equation, so you will have so we have resolved by the partial fraction, apply a is equal to minus 1, b is equal to 4, and c is equal to 4, you will have the after resolved by the partial fraction. Now in that stage you have to take the inverse transform, Laplace inverse of small y of s, Laplace inverse of that one, and Laplace inverse of 7 1 over s minus 4, Laplace of 1 over s minus 2 square, 4 Laplace of 1 over s minus t. So Laplace inverse of y of s is denoted by capital Y of t, and we have represent the solution of this y of s, capital Y of t, minus 7. What about the 1 over s minus 1 Laplace inverse? In fact, this is e power t. 1 over s minus 2 square. First we write t because of this 2, and then we write 1 over s minus 2 Laplace inverse. This is e power 2. This is by the multiplication of t property. You can see the lecture in Laplace transform series, from which you can have the idea if you don't know about the Laplace of 1 over s minus 2 whole square plus 4 Laplace inverse s minus 2, it is e power 2t. So minus 7 e power t, 4t e power 2t, here e power 2t is a common, 4 e power 2, so t plus 1. This is the last solution of our given problem. So we have completed the solution of initial value problem as given. I request you kindly subscribe the channel and like the video as you find more videos on the mathematics topics. Thank you.